Good morning, everyone. Before I start the presentation, let me introduce myself. My name is Mukundan, son of Rajaselvan Elias Rajamohan, and my matric number is S77569. And today I will be beginning by introducing the United States of America, a nation recognized as the world's largest economy and a global leader in technology and innovation. Geographically, the US is uniquely positioned with access to the Atlantic, Pacific, and Arctic Oceans, giving its vast opportunities to develop both renewable energies and marine biotechnology. In this presentation, we will focus on how the US is balancing economic growth with sustainability. Specifically, I will highlight the three best green technology and the three best blue technology. These combinations shows how the US is setting benchmarks for clean energy transition and sustainable development worldwide. By leveraging this geography, resources, and innovation, the country demonstrates how both the green and blue economics can drive a more sustainable future. On this slide, we are looking at green technology. At this core, green technology is about developing systems and solutions that are conserve the environment while reducing the negative impact of human activities. The first pillar is terrestrial energy. This includes the land-based resources like solar farms and wind turbines, which provide clean and renewable power. Next, we have decarbonization. Technologies such as carbon capture and green hydrogen that helps us cut emissions and transition away from fossil fuels. And finally, sustainability. This focusing on the building eco-friendly infrastructure and designing waste-free systems and support long-term environmental health. Together, these three areas shows how green technology is shaping a cleaner, more resilient future. Now let's look at blue technology. This concept is all about using ocean, marine and aquatic resources in a sustainable way, which is driving economic growth and creating jobs while protecting the health and marine ecosystem. The first pillar is marine biotechnology. These involve harvesting seaweeds, microalgae, and coastal organisms to create a bioplastic, pharmaceuticals, and even sustainable food resources. Next is renewable ocean energy. Here, power is generated from the tidal movement, wave energy, and offshore wind arrays, which is turning the natural motion of the ocean into clean electricity. And finally, we have aquatic preservation. Smart monitoring systems are being developed to prevent the overfishing and to track the coral reef recovery and ensuring the marine life continue to thrive. And these three pillars shows how blue technology can balance the economic opportunity with the environmental stewardship and makes our ocean a key driver of sustainability.
Let me begin with the one of the green technology in United States. Before that, let me introduce myself. I'm Tibi Anupram Rash, matrix number S68923. So, green hydrogen technology, an amazing clean energy technology that is expected to play a major role in achieving net zero carbon emission in the United States. Green hydrogen is produced through a process called electrolysis, where renewable electricity from solar and wind energy is used to split water into hydrogen and oxygen. Since renewable energy is used throughout the process, no greenhouse gases are produced. Green hydrogen is considered one of the cleanest energy carriers available today. Unlike gray hydrogen, which is produced using natural gas and release carbon dioxide, green hydrogen is generated using renewable energy source and produce zero direct emission. It is particularly important because it can help decarbonize sectors that are difficult to electrify, such as steel manufacturing, aviation shipping, and also heavy duty transportation. Next, let me talk about the implementation and operation of green hydrogen technology. The process begins when electricity from solar or wind farm is supplied to an electrolyzer. The electrolyzer split water into hydrogen and oxygen. The hydrogen is then purified, compressed, and stored for future use. It can be later used as fuel for transportation, industrial processes, electricity generation, or long-term energy storage. Modern electrolyzers can achieve efficiency between 70% to 85%, making them increasingly available for large-scale development. Now, let me talk about the triple bottom line contribution of green hydrogen technology in the United States. First, economic contribution. Green hydrogen is expected to generate significant economic benefit for the United States. Through the Department of Energy's Hydrogen Short Initiative, the government aimed to reduce hydrogen production costs from approximately $4 to $6 per kilogram to $1 per kilogram by 2030. The US also planned to increase clean hydrogen production to 10 million metric tons by 2030, 20 million metric tons by 2040, and 50 million metric tons by 2050. These investments are expected to create over 100,000 jobs by 2030 and more than 500,000 jobs by 2050. Next, social contribution. Green hydrogen contributes to society by improving air quality and public health. By replacing fossil fuels, they help reduce harmful pollutants such as sulfur dioxide, nitrogen oxide, and particulate matter. This can lower the incidence of respiratory disease and cardiovascular illness, especially in the communities located near industrial areas. Green hydrogen also support a just transition by creating new employment opportunities for workers previously employed in fossil fuel industries. Lastly, environmental contribution. Green hydrogen provides substantial environmental benefits. According to the US Nation Clean Hydrogen Strategy and Roadmap, clean Clean hydrogen could contribute approximately 10% of the economy-wide emission reduction needed by 2030. It is particularly important for reducing emission from hard to abate sectors such as aviation, shipping, steel production, and heavy industries. Furthermore, hydrogen enables the production of green steel and other lower carbon industrial products, supporting a circular and sustainable economy.
Good day, everyone. My name is Loitaksha Analaki Subramaniam, and my metric number is S75897. Today, I will be presenting about electric vehicle or EV technology and its implementation in United States. First, let's understand what is EV technology is. An electric vehicle, commonly known as EV, is a vehicle that uses electricity as its main source of power instead of petrol or diesel. EV are powered by rechargeable batteries which supply electricity to an electric motor that drives the vehicle. Compared to conventional vehicles, EV are more energy efficient and environmentally friendly because they produce little and no tailpipe emission. They also operate more quietly and generally require less maintenance because they have fewer moving parts only. In recent years, EV technology has become increasingly popular due to growing concern about the climate change, air pollution, and the need for sustainable transportation. Example of electric vehicles includes Tesla models, Nissan Leaf, and Ford Mustang Mach-E. As technology continues to improve, EV are becoming more affordable, efficient, and accessible to customers around the world. Now, let's look at how EV technology has been implemented in United States. The United States is one of the leading countries in the adoption and development of electric vehicles. The government has introduced various policy and incentives to encourage customers and businesses to switch to EVs. For example, tax credit and rebates are offered to help reduce the purchase cost of EV vehicles. At the same time, the country has invested heavily in charging infrastructure by installing thousands of charging stations across cities, highways, and public areas. This makes it easier for EV owners to charge their electric vehicle and travel long distance. Major automotive companies such as Tesla, Ford, and General Motors are also investing billions of dollars in EV manufacturing and battery productions. In addition, many public transportation systems are gradually introducing electric buses and other electric vehicles. These efforts have significantly increased EV adoption and help accelerate the transition towards cleaner transportation in United States. Okay, now let's look at EV technology contributes significantly to the economy, society, and environment in the United States. For the economic perspective, the EV industry had extracted billions of dollars in investment and create thousands of jobs. By 2024, in United States had announced more than $180 billion in EV and battery manufacturing investment, supporting the growth of domestic industry and creating employment opportunity across the country. Next, for the social perspective, EV adoption continues to increase. In 2024, EV accounted for approximately 10% of all new vehicle sales in United States, showing that more Americans are choosing cleaner transportation options. The expansion of charging infrastructure has also improved accessibility and convenience for EV users. For the environmental view, transportation is one of the largest source of gas emission in the United States, contributing around 28% of total emission. EV helps reduce these emission because they produce zero tailpipe emission. Studies shows that EV can reduce lifetime greenhouse gas emission by around 50% and more compared to the to convenient gasoline vehicle depending on the electricity source used. Overall, EV technology help create jobs, improve public health, reduce carbon emission, and support transition toward cleaner and more sustainable future for the United States.
Good day everyone, I'm Shariana, year number matric I75647. Today I will present about the geothermal energy system. Geothermal energy is a renewable energy source that comes from the natural heat stored beneath the earth's surface. This heat can be used to generate the electricity and provide heating for buildings and industries. There are several advantages of geothermal energy. First, it produces the electricity continuously because underground heat is available 24 hours a day. Second, it is environmental friendly as it releases the very low greenhouse gases emission compared to fossil fuel. Third, it helps to reduce the dependence on non-renewable energy sources such as coal, oil, and natural gas. Geothermal energy is important because it provides a stable and reliable electricity supply while supporting the global efforts to reduce the carbon emission and achieve the sustainable development. Now I will explain about how geothermal energy works and its contribution. The process begins when underground heat warms water deep beneath the earth's surface. The heated water turns into steam and rises to production wells. The steam then spins a turbine connected to a generator which produces electricity. Finally, the electricity is transmitted to power lines to homes, businesses, and industries. Geothermal energy also brings many benefits. From an economic perspective, it creates the job opportunity, attract investors, generate the revenue from electricity production, and improve the energy security. From a social perspective, it provides a reliable electricity supply, support the school and hospital, improve the quality of life, and create the employment opportunity for local communities. From an environmental perspective, geothermal energy produces very low carbon emission, help to reduce the air pollution, use renewable heat from the earth, and require relatively small land areas compared to some other energy sources. In conclusion, geothermal energy is a sustainable solution that contributes positively to the economic, society, and environment. Thank you.
Next, I introduce myself. My name is Dakshayani Anaprabaji Sandiswaran and my ID number is S75509. Today, I will be presenting on aquaculture system, which is a blue technology used in United States. Aquaculture refers to the farming of aquatic organisms such as fish, shrimp, shellfish, and seafood in a controlled environment. It has become one of the fastest growing food production sector due to the increasing demand for seafood and the decline of wild fish stocks. Globally, aquaculture production exceeds 130 million tons and contribute more than 57% of aquatic food products consumed worldwide. Modern aquaculture uses advanced technologies such as recirculating aquaculture system (RAS), automated feeding system, IoT sensor, and water quality monitoring equipment to improve productivity while protecting the environment. Let's see how aquaculture systems are implemented. Aquaculture system implemented in freshwater, coastal, and offshore environment. Freshwater aquaculture produce species such as catfish, trout, and tilapia, while marine aquaculture focus on salmon, oyster, mussels, and clams and seaweed. One of the most important technology used in the recirculating aquaculture system RAS. This system continuously filter and recycle water through a closed-loop process, reducing water consumption and environmental impact. Farmers also use automated feeding system and underwater sensor to monitor fish behavior, water quality, oxygen level, temperature, and pH levels. This technology improves productivity and ensure healthy fish growth. See the contribution of economy, social, and environmental. First of all, economic contribution. Aquaculture provides significant economic benefit to the United States. The industry generates approximately 1.5 million US dollar annually and creates over 22,000 jobs in farming, processing, transportation, research, and marketing. Aquaculture also help reduce dependency on imported seafood, improve national food security, and support economic growth in coastal communities. Furthermore, investment in technologies such as offshore agriculture and RAS facility create new business opportunity and strengthen the competitiveness of the U.S. seafood industry. For the social contribution, aquaculture contribute to society by improving food security and public nutrition. Seafood is an important source of protein, vitamins, minerals, and omega-3 fatty acid that support human health. The industry also create employment opportunity, especially in rural and coastal community where alternative job opportunities may be limited. In addition, collaboration between aquaculture company, university, and research institution help to develop their skilled workers and promote community development. Okay, lastly, environmental contribution. Aquaculture also provide important environmental benefit. First, it reduces pressure on wild fish population by producing seafood through controlled farming instead of harvesting from natural ecosystem. Second, RAS system can reuse up to 99% of water, reducing freshwater consumption and waste discharge. Thirdly, shellfish such as oyster naturally filter water. In fact, one oyster can filter approximately 50 gallons of water per day. Seafood farming absorbs carbon dioxide and excess nutrient from the ocean, while integrated multi-trophic aquaculture or IMTA reduce waste water by allowing one species to use the waste produced by another species.
Introduction to desalination technology. Desalination is the process converting saline water such as the seawater into fresh water suitable for human use. This technology has become increasingly important due to the global water crisis driven by climate change, drought, and the depletion of natural freshwater sources like river and aquifer. In the United States, there has been a shift from relying on traditional water system toward a more resilient alternative like desalination. The industry has grown significantly, reaching about $3.5 billion in 2024 and projected to expand to $9.2 billion by 2035. Modern desalination mainly uses reverse osmosis technology, where high pressure around 800 psi force water through advanced membranes that remove over 99% of salt. With innovation like energy recovery devices reducing energy use by up to 60%, desalination is now reliable and increasingly efficient solution for sustainability. Next, how desalination is implemented. Desalination implemented is through two main technologies, thermal and membrane system. Thermal desalination use heat to evaporate water and then condense it into fresh water, but it is highly energy intensive. Today, most plants use membrane technology, especially reverse osmosis, which is much more energy efficient. The process begins with seawater intake followed by pre-treatment to remove particles and impurities. Next, high pressure pump push the water through semi-permeable membranes that separate salt from water. After that, the water undergoes post-treatment to ensure it is safe for consumption. And finally, it's distributed to user. Over time, there has been a major shift from older thermal system, which use 25 to 40 kilowatt hour per cubic meter, to modern reverse osmosis system that use only 3 to 4. Additionally, many plants have now integrate renewables energy sources like solar and wind, especially in states like California, Texas, and Florida. Next, sustainability impact. Desalination contribute to sustainability in three key areas: economic, social, and environmental. Economically, the industry is a growing rapidly, supporting sectors like agriculture, manufacturing, and urban development while becoming the more cost effective due to improved energy efficiency. Socially, desalination enhance water security by providing a reliable supply even during drought, which is critical for growing population and public health. Environmentally, modern desalination plants are designed to reduce their impact. Many facilities now use renewable energy sources, lowering carbon emission. In addition, advanced brine management systems such as a multi-pot diffuser help protect marine ecosystem by safely dispersing salt waste. Overall, desalination play a vital role in reducing dependence on natural freshwater source while supporting long-term environmental resilience and sustainable development.
Moving seamlessly into our next core technology, let us look at wave energy. Scientifically, wave energy is classified as a secondary solar source when solar heating creates wind currents moving across our vast oceans. That intense kinetic energy is transferred directly into the water, producing wave. What makes wave energy an absolute game changer is its sheer density. Ocean water is roughly 800 times denser than wine or air. Because of this immense fluid density, wave technology yields an incredibly consistent, reliable base power compared to other intermittent renewables. When we look at the potential scales, the numbers are monumental. Within the US continental scope alone, there is a theoretical ocean energy capacity of 2,640 terawatt hours per year right at the shell's boundaries. Furthermore, implementing this technology does not mean sacrificing coastal beauty. It offers a dual-purpose defense, meaning these systems can cleanly integrate with existing standard coastal defense barriers. This allows us to harvest massive clean energy with a virtual zero visual or landscape footprint on our shorelines. Next, looks at the implementations of wave energy in the US. Now that we understand the mechanics, let's explore how this power is actively being conceptualized and implemented. Focusing on the US infrastructure framework, we can break this deployment down into five critical impacts. First, it supply national demands. Wave energy systems are credibly engineered to cover anywhere from 6.5% up to 20% of the total US electricity grid load, providing a massive buffer for the national power supply. Second, it replaces costly fuels for isolated native Alaskan and Hawaiian grids that rely heavily on the expensive, volatile offshore diesel fuels imports. Say wave energy can completely offset that reliance with localized clean marine power. Third, it's revitalized ports and weldings. Deploying this massive ocean structure acts as an economic catalyst, stimulating over 5,000 billion in harbor upgrades and generating 1.8 billion in US shipyard orders. Fourth, it's secure critical coastal defense. This system serves a dual operational purpose by powering vital naval surveillance systems, oceans monitoring sensors, and offshore utility grids. Finally, we see plunging cost. While early-stage technology is always an investment, the levelized cost of energy is projected to drop drastically from baseline of 0.57 per kilowatt hour down to highly competitive 0.07 per kilowatt hour by the year 2050. Next, let's look at the triple bottom line contribution. To bring this all together, the true value of the wave energy is best evaluated through the triple bottom line frameworks, analyzing its long-term economic, social, and environmental contribution. Look at the economic contribution. Wave technology is a powerful driver for domestic maritime manufacturing. As mentioned, it channels over 1.8 million into vessel orders and 5 million port revitalization schemes, while completely stabilizing fragile economies in Alaska and Hawaii by eliminating volatile diesel import costs. From a social contribution standpoint, this technology directly safeguards the 40% of the American living in coastal countries. By shifting critical grid nodes offshore, we inherently protect inland infrastructure against targeted cyber attacks. On top of that, by demonstrating high pollution coal plants in favor of marine energy, we directly mitigate the severe respiratory issues like asthma and vulnerable port communities. Lastly, the environmental contributions are profoundly clear. Wave energy operates with absolutely zero direct greenhouse emissions. Because these installations take up zero onshore land acreage, they completely avoid the visual and land-based wildlife conflicts common with large wind solar farms. To ensure the marine ecosystem remains pristine, the technology utilizes 100% biodegradable hydraulic fluids. Ultimately, wave energy proved to be highly sustainable strategy powerhouse across all three pillars.
As we conclude, it's important to recognize that the United States has positioned itself as a global leader in sustainability by integrating the principle of the green economy and the blue economy and the sustainable development goals. The country is balancing economic growth with environmental protection and social well-being. On the green economy side, the US has made the major progress in areas like green hydrogen, carbon capture, solar and wind energy, and electrical vehicles, all of which reduce emissions, improve efficiency, and create new jobs. From the blue economy perspective, the nation is effectively using the marine resources through innovations such as ocean terminal energy conservation, marine biotechnology, and sustainable fisheries, while also promoting ecosystem conservation and coastal resilience. Overall, the US has the financial strength, technological expertise, and institutional support to lead global sustainability transitions, though continued focus on climate action, infrastructures, modernizations, and environmental equity will be essential moving forward. Thank you.